to the lesson that you missed. So, after you do the warm-up in the Google form, you'll see a series of example 1 through example 10, and they don't have any problems. That's because the problems we did together up on the board, more or less together. And so, to give that same set of examples, we're going to do it here, and then you're going to have to pause the video at regular times and go and type in your answer into the Google form. There you go. So this is example 1 here. Our first step when we have problems dealing with special angle pairs is to determine what type of special angle pair it is. These are complementary angles. You can tell because of the 90-degree, the right angle box in the corner. So complementary angles add up to 90 degrees. And just as before with the angle addition postulate stuff, where we had part plus part equals whole, it's the same idea here. Part plus part equals, in this case, 90. So 50 plus 8a equals 90. Now go ahead and pause in order to solve that equation for a. Only type in the answer, don't put like a equals into the Google form. Example 2 is here. Now again, our first step is to always determine what type of special angle pair it is. In this case, these are also complementary because of the little corner box. So our setup is going to involve equals 90. And again, it's part plus part. The parentheses don't matter too much, so you can just kind of ignore them for these problems. That's not very lined up, but that's okay. So 52 plus 4r minus 6 equals 90. You would combine your like terms first. Be careful. A mistake I saw over and over again during the day was combining like terms incorrectly. When they're on the same side, you just put them together as normal. You don't do like plus 6. So it would be 52 minus 6. In this case, I think it's 46. Plus 4r equals 90. And again, go ahead and pause and solve that for r. Example 3 is here. First step, determine what type of angle pair this is. This is also complementary because of the corner, the box that indicates a right angle. Oops. So just as before, we're going to have something plus something equals 90. Now our somethings in this case are 3p minus 5 plus 5p plus 7. Solve for p. Example 4 looks a little different. Let's zoom out maybe a little bit. So example 4 looks a little different. Our first step is to figure out what type of special angle pair this is. A lot of people guess that it's vertical angles, because vertical angles are always formed by intersecting lines like this. However, if this was a vertical angle problem, we would have like the 2p here and then another thing here, or the 104 here and something here. Vertical angles are across from each other, never next to each other. So these can't be vertical. And they also can't be complementary because we don't have the little box that indicates a right angle. So the other option that we have is supplementary. Okay, are these supplementary? Do they form a straight line when we put them together? So that's one of our angles, and that's the other. Yes, they form a straight line. So these are supplementary. Now, supplementary angles, the important thing about them is that they add to 180 degrees. So go ahead and set up and solve this problem. Again, solve for P. Example 5, we have 9v plus 3 and 60 degrees. First step, figure out what type of angle pair this is. These are also supplementary because they're on the same side of a line. They form a line when we put them together. So again, supplementary equals 180. So in this case, our parts are 9v plus 3 and then 60. Solve for v. Example 6. We've got 8y and 6y minus 2. We have to figure out what type of special angle pair this is. This one looks more obviously like supplementary because we only have the one pair. We're not given like the full x like over here. So these are supplementary as well. Set up and solve for y. For y. Example number 7. Let me try to zoom out a little bit. Example number 7 looks like this. We have a 60 degrees over here and a 60 degrees over here. Now we have to figure out what type of special angle pair this is. These ones are vertical. They are reflected over a central point, in this case, this intersection. So if you think of these as triangles, this is a triangle just kind of flipped on its head, and it turns into this. The important thing about vertical angles is that they are equal. They are congruent. So, if this one equals 60, it's equivalent to 6t. These have to be the same. So when we set up a vertical angle problem, we're going to set them up equal to each other. Go ahead and pause and solve. Probably don't need to pause for very long. Example 8, similar idea. Are these vertical angles? They are, because they are opposite each other. Vertical angles are never ever next to each other. So these are opposite. Again, you could think of it as triangles flipped over, or I guess fish kissing, if that's your preference. So again, vertical angles are equal to each other. So 123 equals 2v plus 1. Solve that. Then we have example 9. Set up and solve this. Finally, example 10 was a bit of a, not really a challenge, but it looks a little different than the others. In this case, we're actually given 3 angles rather than just 2. But we still have to try to notice, okay, what type of relationship is this? They're not going to be vertical because there isn't like a big X intersection. We do have a right angle box indicated here, but there isn't like 2 angles inside of the right angle, so I don't think it's going to be complementary. Look at supplementary, okay? So if this is one of our angles, this is one of our angles, and this is one of our angles, aha, they form a straight line together. So even though it's 3 pieces now instead of just 2, our total is still going to be 180. So now again, we add up our different parts. So we have 41, we know that. We have p minus 3. And then we have this third part. Again, this box indicates a right angle, and a right angle is 90 degrees. Solve for p.